we're going to be multiplying a fraction by a fraction using an area model. In this case, we will have one fraction that is less than 1 and one fraction that is greater than 1. I'm going to write my equation. My equation will be 1 and 2/3 times 3/4. Now, in order to do the area model, we must label a length and a width, because that's how we find areas, by multiplying length times width. We start with our first number, which is 1 and 2/3. I think to myself, how many holes will I need to represent 1 and 2/3? Well, one hole will not do, because I already have 1 here. I need to represent 1 and 2/3 more. So I will need 2 holes in order to do that. So I will go ahead and have 2 holes here. So I know that because my 1 and 2/3 is the only one that's greater than 1, that it must be my width that's labeled 1 and 2/3, the way that I have it set up. That means that my length will be 3/4. Now what I need to do is exactly the same thing I did when multiplying a fraction less than 1 by a fraction less than 1, and that's partition my holes. We'll start by partitioning my length. My length is 3/4, and my denominator is 4, so that's how many partitions I need. So I will go ahead and partition my holes into fourths. Now notice, I didn't just do one of my holes into fourths, I partitioned both holes into fourths, or all of my holes that I need into fourths. I have 3 of those fourths, so 1 of my fourths, 2 of my fourths, and 3 of my fourths, because the numerator tells me that I have 3 fourths. Next, I will go ahead and partition my 1 and 2/3. What do I partition each hole into? Well, I'm counting by thirds. So I know this is 3/3 and I have 2/3 after that. So each hole must be partitioned into thirds. I'll partition the first one into thirds. This area is 1/3. Here's a second and here's a third. That's one hole. And then I'll partition this hole into thirds. Now, I will go ahead and I will shade in 1 and 2/3. Well, one hole, so I'll shade in, I will shade in one hole, which is 3/3, and then I will shade in 2/3 more. Here's another third and another third. Now I can go ahead and I can see which areas overlap, and I can see that it's this area here within my red box. And now to get my answer, I will go ahead and I will count how many pieces overlap. I will write that in red ink. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 is how much I have, so that will be my numerator. Now, in order to find out my denominator, I must count how many total pieces is one hole partitioned into. And it's very important to remember that I am only talking about how much is one hole partition. My hole, if this is 1/3, this is 2/3, and this is 3/3, this is where one hole is. So I'm not going to count all of these pieces on the right-hand side over here. I will just count one whole square and what is partitioned into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So my answer is 15/12, which of course I can convert into a mixed number. How many times does 12 go into 15? One time. And if I take away 12 from 15, I'm left over with how much? I'm left over with 3, And of course, those are 3/12. And that's how you multiply a fraction by a fraction when one is greater than a whole and your second is less than a whole.